Buongiorno baddies, welcome back to another video. Today's description is a positive number is written in scientific notation if it is written in the form of a times 10 to the power of b, where a is a number with 1 is less than or equal to a, and a is also less than 10, not equal to 10. A is just less than 10, or else that would be another power of 10. And b is an integer. For example, 38100 is written in scientific notation as 3.81 times 10 to the power of 4, and 0.025 is written in scientific notation as 2.5 times 10 to the power of negative 2. So our first actual problem here is write the product 3 times 10 to the power of 5 times 4 times 10 to the power of 6 in scientific notation. And since this is all multiplication and using the associative property, we will completely disregard the use of parentheses in this case because it's all multiplication and it does not matter what order you do it in. Plus, that also makes our problem easier. So, if we remove these useless parentheses, we will get an equation of this. And now we can mix and match to make our work easier. So, for example, the 3 and 4, the 10, 5, and then 10, 6. We're going to get 12 times, since using that a useful little shortcut, where when you are multiplying numbers with exponents, you add the said exponents. We get 10 to the power of 11. But that is not scientific notation, because a is not less than 10. So whatever shall we do? We will take a 10 from the 12 and give it to the 10 to the power of 11. Because that is still equal, it is just now in scientific notation. So this is equivalent to 1.2 times 10 to the power of 12. Yay! Oh, wait. Okay, I'm just going to use yellow to highlight the answers from now on. Write the quotient of 3 times 10 to the power of 2 divided by 5 times 10 to the power of negative 3 in scientific notation. This is the same idea. We will put this into fractions to make solving easier. And to comprehend, mostly, actually. But we will not talk about that. So, 3 divided by 5 is 0.6. Multiplied by, since this is division, we will subtract the exponents instead of adding them. So, 2 minus negative 3 is the same as 2 plus 3, which is then 10 to the power of 5. But this is still not greater than or equal to 1. A is not A-ing in this case, actually. So, we are going to have to take a 10 from the 10 to the power of 5 and give it to A to make this A. To make A. Basically. So we will get this number. I'm going to highlight this in green because it wants to be a quick, So moving on to problem number 3. If a positive integer n is expressed in scientific notation as a times 10 to the power of b, how many digits does n have when written out? And since the above area told us that in scientific notation, a only has 1 digit to the left of the decimal point, because if it was 10, then it would have 2 digits, but it can't be 10. It can't be anything greater than 10. Sure, it might have digits to the right of the decimal point, like 1.2. That's still scientific notation. But it only has 1 to the left of it, is what I'm saying. So, when we have a times 10 to the power of b, when you multiply a number by 10 to the power of something, it is moving back the decimal point by to what power that 10 is raised to. For example, if we have 3 times 10 to the power of 2, which everyone knows is 300, when you really think about that, it's moving back the decimal point 2 times because the 10 is raised to the power of 2. So the 3, the decimal point is here, it moves back 1, 2, leaving space for 2 zeros because you have nothing else to jump over. But if it was a decimal, then it would jump from the front of the decimal to the ones behind it to, like for example, like 1.6 times 10 to the power of 2. It's still jumping back 2 times. So when it jumps back 2 times, it has to jump over the 6 first and then jump over a 0 because you don't just add the zeros behind the 6. So that is the same idea of the a times 10 to the power of b. We are jumping back the decimal point b times. However, before you're just like, oh no, so that means that there's like b digits, right? No, not exactly. Because we still have a in the front of it, just like how here 300 doesn't have 2 digits, 300 has 3, because this is our a and this is our 10 to the power of b in this case. So basically, we're going to have the first digit always counts as 1 digit because we can't go past 10. So that means that it's always going to be having 1 plus b digits, because the 1 simplifies the a in the front of the equation that has 1 digit to stand before the b's, if that makes sense. So the amount of digits that n has when written out is 1 plus b. So yeah, that's the end of this video. I hope you guys enjoyed, and I hope you guys learned something new, and I shall see you guys on the next one. Thank you. Bye bye.